All right, new video. Let's do example 9.5. This is in the section that has to do with the electronegativity. So that funky looking periodic table, basically, and also you have to use this table 9.5. So example 9.5 says, predict if the bonds are going to be covalent, polar covalent, or ionic. So hydrogen and oxygen. Let's see, and I'm going to write all of these. Carbon and bromine, potassium and chlorine. Okay, so you go up here at this table and you have to look at the numbers. So you've got hydrogen, which is 2.1, and oxygen, which is 3.5, and you just take the difference of that. So 3.5 minus 2.1 is 1.4. So then you gotta look on here and you gotta determine, what is that? Well, it's polar covalent. Okay, go up to the next one. Let's see, we've got 2.5 and 2.8. So 0.3. Well, go on this little table here. If it's less than 0.5, then you've got a covalent bond. And then last, you've got potassium, which is 0.8, and chlorine, which is 3.0. So that would be what, 2.2? And so if you look at this table again, you've got, if it's 1.7 or greater, then you end up with ionic. Oops, sorry. Okay, so I honestly think that electronegativity is pretty easy because basically all you're doing is subtracting. Example 9.6, it already gives you the answers here. It says to predict, again, if they're covalent, polar covalent, or ionic. First one is calcium and oxygen. Second one is hydrogen and chlorine. Sorry, I'm a little distracted because I think my daughter's mad at my husband or something. I don't know. She's doesn't seem happy up there. Oh well, he can handle it. All right, let's go back up here and see what we've got. So we've got calcium, which is 1, and oxygen, which is 3.5. So you end up with 2.5. So that's going to be ionic. Hydrogen is 2.1 and chlorine is 3.0. So that's 0.9. Which again, if it's 0.5 and between 0.5 and 1.7, then that's polar covalent. And then lastly, you've got carbon, which is 2.5, and oxygen, which is 3.5, so you end up with 1. So again, you end up with polar covalent. Okay, so that is the end of that one. Let's see how to go on to the next section here. Here we go. All right, compositions and compounds. This is where I think we had to start doing some of the crossover technique. All right, so let's see, example 9.7. It says, name the following compounds. So we've got LIF. Okay, now this is where you're going to need to, for some parts of it, you're going to want to have, it makes me mad because it's in a different section, but you're going to really want to use the table 9.2 and 9.3. Okay, so the first one, not so bad. It's just these are all ionic compounds, but they're wanting you to figure out some other things on a couple of them. So the first one, you just name the metal, and then you name the nonmetal, but you end it with "ide." So lithium fluoride. Now, the second one. This is where I want to go back a little bit. And I think this one was in, I think it's in this section where you have to look at this table. Yeah. Okay. Look here really quick. See how at the bottom of table 9.2, lead is either 2+ or 4+. So that means it's a variable charge ion, which means that, hold on, which means that it can have a couple of different charges.
Mommy.
Hold on, okay?
Okay.
All right, so let me go back to that example really quick. Let's see right here. Okay, so see how this one says PbF2? All right, since that lead it can either be +2 or +4, we have to tell which one it is. Well, how do we know which one it is? Well, if we take this 2 right here and we pull it up, and this 1, you know, that's not there but is there, we pull it up, then that shows us that that's lead 2+. Really, it's like this. Lead 2+. So the way that you write it is you write lead with a Roman numeral 2 fluoride. Whoops. You really need to distinguish what the charge is with a Roman numeral. All right, so I'm going to stop the video and I'll start another.